Cool. So first things first, I'm going to share my screen. All right, so the first thing I want you to do is make sure you have Anaconda Navigator open. Inside Anaconda Navigator, if you go to the little Environments tab, you should have a base environment. If it's a brand new installation of Anaconda Navigator, you should just have your base environment. If you've had Anaconda Navigator for a while, you may have created more than one environment. I generally only keep the base environment, but that's because I use the same packages over and over and over again. If you specifically wanted specific packages for specific uses, you might create another environment. But we're going to search for Numpy. And you're going to look for not installed, or you're going to look at all. Now, for me, as you can see, I have Numpy installed because it's got this nice little green check mark by it. If you do not have Numpy installed, check the box next to it. And when it says, when it gives you a, it should give you a something that looks like this, an apply button at the bottom. You're going to hit apply, and it will automatically download and install for you. So we're going to do 3 different packages that way. I'm going to do Numpy. We're going to do Pandas. Oh, I'm going to go ahead and update Pandas because mine needs to update. So when you hit apply, this is what should happen. Get a little box and the bar that says solving package specifications. So you can install packages one of 2 ways. You can do it this way. You can also open up a terminal, and I'm going to show you how to do that in just a second. In fact, I'm going to cancel this and do it in a terminal. So if we open up a terminal, we can install a package by conda install and then the name of the package, like Pandas, for example. I already have Pandas, so I'm going to do conda update Pandas. So we need 3 packages. We need Numpy, we need Pandas, and we need Matplotlib. And while we're waiting for that to solve, I'm going to show you how Matplotlib is spelled. Make sure Matplotlib is checked and installed. Let's see. Still solving my environment. Okay, now, does everybody have all 3 of these packages installed, or are we waiting still?
Oh, there we go.
Given that most everybody installed Anaconda lately, I think that Numpy and Pandas come with Anaconda. But sometimes they do not. It's just why I was making sure that everybody has it. Oh, yes. Yes, Glenn. On Windows machines or any machine that's not a Mac, generally you would open up Anaconda prompt instead of a terminal. Terminal just happens to be the I'm going to update Matplotlib as well. Oh, okay. On Windows, though, instead of terminal, you open up Anaconda prompt. So Matplotlib, Numpy, and Pandas are the 3 packages we're going to use. Update Matplotlib right quick. And then we will start using stuff. Pandas. Now, once you have Numpy, Pandas, and Matplotlib installed, we can move forward with using them. Excellent. Everybody has everything installed. Cool, cool, cool. We finish updating mine and we'll be good to go. Solving the environment is the part that takes the longest for some odd reason. But well, I will go ahead and talk about or do a short review of what we talked about last class. So last class, we talked about how Python has a specific data type, and the specific data type that Python in base Python is a list, generally. All right, cool. So now that we have everything updated, we can go back to home, and you're going to launch a Jupyter Notebook. I already have one. So if you launch Jupyter Notebook, you're going to then go into a wherever folder you would like your Jupyter Notebook to be saved in. Because when you open up Jupyter Notebook, it's going to give you your base file system. You're going to click, I clicked on desktop and I created a folder on my desktop called Pandas for today. Okay, so once you open up a Jupyter Notebook, we are going to import the 3 packages that we talked about. We're going to import Numpy as NP. And by importing Numpy as NP, we're giving Numpy an alias. The reason that I am importing both Numpy, Pandas, and the Matplotlib PyPlot module here with aliases is because base Python has a bunch of functions that have the same names as functions in Numpy and Pandas and Matplotlib. And I would like to be able to use the functions both of base Python and within each of these packages. And if I give each package an alias, the functions that are the same name do not mask the base Python functions. For example, max and min potentially are things that potentially would get masked if they were to, if they had the same name, but I think in NumPy, max is actually Amax. And this last line here, I'm using pandas to read in a CSV from a website. So in the package called Seaborn, there are a bunch of different data sets. Because we're not going to be using the Seaborn package, I simply am downloading the data straight from this GitHub page. You can see there's a bunch of different CSVs here. We're probably going to pull in more than one. I pulled in the iris data set. This iris data set is the same as the iris data set that is in R, if anybody has used that particular one. Maybe. Okay. So first thing I want to do is I want to talk a little bit about data types. So once I have run that, I have now imported NumPy, Pandas, and Matplotlib to be able to use them. But I would like to talk, like I said, I would like to talk a little bit about data types first. Now, remember, we played with lists last class. So I'm creating a list called L. And remember, we can't do math with lists. Now this particular list has 5 things in it and they're all numbers. Unfortunately, we still can't do math with it. We can't say L plus 1, for example. The plus here for a list can only concatenate to the list, and since all of the things in our list are integers, since we are playing with a list, the only way we can concatenate to a list is having another list. However, NumPy changes that for us. NumPy's base data type is an array, specifically an ND array. Now, ND stands for n dimensions, or n-dimensional, which means our particular, the size of our array is anything we want it to be. It can be a single dimensional array, which is a vector. It could be a 2-dimensional array, which is a matrix. It could be a 3-dimensional array, which is a tensor, and so on and so forth. Generally, I only work with 1-dimensional and 2-dimensional, sometimes 3-dimensional arrays, but you can work with as many dimensions as you like. The more dimensions you have, the longer it takes to access everything, but that's totally fine. Okay, so we have a list, but now I would like to change our list into an ND array. So I'm going to call it L2. And I'm going to look at my NumPy package and see what I got. If you type in np dot, because we imported NumPy as np, you'll get all the different possibilities inside NumPy. I'm looking for ND array. Or am I looking for just array? Yeah, I'm looking for just array. So I can take my list that I called L and change it into an array. Now, it looks basically the same, except for now it has array around it. But now I can do this. Ta-da! Now, ND arrays have a bunch of different really cool functions that go with them. So let's look at L2 dot. All right, remember, Python is a object-oriented programming language. So each of the things that we create in Python have a bunch of methods and aspects built in. So the array has a bunch of things that you can do. And we can take our array and take it back to a list by doing .toList here. I'm not going to do that. Let's play with some of the stuff that we can do now that we have a thing. If we sum up our list, we now get 15. And it's our array, because we no longer have a list, we have an array. We can find the max. We can I believe there's an index. No, okay. We can do a cumulative sum. Ta-da! This takes each of our different. So you do the name of the variable dot and then hit a tab, and it should pop up. Did I forget to say tab? Sorry. If you did not import Numpy or whatever, if you haven't run the first cell where we import Numpy, Pandas, and Matplotlib, you won't get the dropdown either because it doesn't know to look for it. It doesn't know that that's a thing. Tab isn't working. That is, I have no idea then. I'm so sorry. And no, it should just be a default. Make sure that the cells are all code cells and not like markdown cells. And make sure it's Python 3 that we're working in. But the other thing that I should mention is that ND arrays do every bit of math that we're going to do to them element-wise, which is basically how we would do vector addition, vector subtraction. We can also add L2 to itself. So we've added the first item in the array to itself, second item in the array to itself, the third item in the array to itself, etc., etc. We can also multiply by 2, which should give us exactly the same array. because adding it together and multiplying it by 2, same thing. But ND arrays are really useful when it comes to doing all kinds of data analysis. And we are going to toggle between the 3 different data types that we're going to go over today, which are arrays, series, and data frames. All right, so we played with arrays a bunch. All except for, indexing into arrays. We gotta talk about that. Right, so remember when we talked about Python last class, we talked about how Python is indexed at, or Python indices start at 0. So the indexing for Python starts at 0. So if I want the first thing in L2, just like if L2 was a list, I would do L2 of 0. Same, if I want the second thing in L2, I would do L2 of 1. Oops. So on and so forth. If L2, however, was a 2-dimensional array, which I'm going to make one of those now, L3, np.array. So we're going to make a 2-dimensional array by putting in square brackets here and adding 2 different arrays together. Wait. Yeah, I think that'll do it. Yeah. So what happens when we create a 2-dimensional array, we put in each row separately. So you can see that that first one, that L2 is the first row, and the second L2 is the second row. We could also make one by saying np.array, and then put in square brackets, and then put in extra square brackets for each row. Now we have 2 matrices. So a matrix is a 2-dimensional array. And if we want to get something out of L4, for example, we have to put in both the row number and the column number that we want. And the way the indexing works for arrays is that you put in the row number first and then the column number. So we want something out of the first row, we're going to use 0. And the first column, we're also going to use 0. If we want, however, the whole first row, for example, that is just one array, a 1-dimensional array. So when we pull out the whole first row, we get a 1-dimensional array instead of a matrix. We can also get the whole first column, which is also a 1-dimensional array. We can also get it out as a matrix by saying 0 through 2, comma 0. Wait, that was supposed to give me a matrix. I'm sorry, I thought that was supposed to give me a matrix. It still gave me a one-dimensional array. Um, Give me a second. Nope. Okay. Oh, I know what it is. I needed to do 0 through 2, 0 through 1. There we go. That's what it was. If you put in 2 different lists as the indices, you will get out a matrix instead of a single dimensional array. Even if well, if you do the colon, comma, colon, then you're just going to get out the original matrix. I was trying to get a subset of the matrix, but as a matrix. And so, yeah, you would get out a matrix by doing colon, comma, colon, but it would be the whole thing. But yes, if you put in 2 different lists as your indices, you're going to get out a matrix instead of a single dimensional array, even if whatever you're pulling out is just the first column, which is what I've done here. Alrighty, so we talked about arrays. We've done some math with them. We pulled out the maximum. We've done a sum. I'm sorry, there was a question?
Sorry, could you go back to the first cell again?
Oh, absolutely.
No, that's what I have. Sorry, my import statement doesn't seem to be working.
Oh, what kind of error are you getting?
Oh, it's just none of those NP command, like the dropdown doesn't come up, and none of those NP commands work.
And you're using np dot.
Yeah.
And you ran the cell.
Yeah.
And then when you ran the cell, it didn't give you an error?
No. I just wanted to check that I had the wording correct, but no, it is. That's what's there.
Huh. And next to the cell, you have a 1, right?
Yeah. Like I said, the using a new interface is like setting up a new interface is always the hardest part of a new language for me for some reason.
Would you mind sharing your screen so I can see what's up?
Okay.
So Glenn, what I was pulling out before was I was just pulling out the first column of the matrix. But I was trying to pull it out specifically as a oh, you have curly brackets.
Sorry?
On your L equals, that's curly brackets. You need square brackets. So that should work now. Okay, and if you just do L2 enter, or L2.sum.
Oh, okay.
Yeah, so the curly brackets make a dictionary, and the square brackets make a list. So what we did was we created a list, and then we changed it to an array with the np.array.
Okay, yeah, see, that's just like a minor, that's a particular language feature.
Yeah. Sorry, so we only use curly brackets for one type of data in Python, and that's a dictionary. I'll talk a little bit about dictionaries in just a few minutes, but or when we talk about data frames, because I'm going to use a dictionary to create a data frame, but they're not the main thing in Python.
Yeah, no, I couldn't tell which it was on the screen, so I guess I guessed wrong.
No worries. I will zoom in then. Obviously, it's not big enough. There we go. How's that?
Thanks.
No problem. Okay. So Glenn, you asked what variables was I using? What did I pull out? Okay. So I was using L3, which was a matrix that had, or I'm sorry, L4, which was a matrix that has the first row is 1, 2, 3, and the second row is 4, 5, 6. And so you can see it's an array, and we can tell that it has 2 dimensions because it has a row with square brackets, comma, and another row with square brackets around it. When I use a list, the 0, 2, 0, 1, these are both lists to index into my L4, I pull out a matrix, a 2-dimensional array, instead of a single-dimensional array. Did that answer your question?
So I guess my question, can you hear me?
Yes.
So the 1 and the 4 in your brackets, the 1 represents what? Excuse me, not that. Go back down. I said that wrong. The 2 and the 1. What is the 2 and what is the 1 for?
Here?
Yes.
Okay, so I created a list, and if you remember last class when we talked about creating ranges in Python, it doesn't include the last number. So what 0, 2 does, what 0, 2 does is creates a list that is 0 and 1 in indices.
So that's the 0 row and the 2 column?
No, it's the 0 row and the 1 because it creates a list that's just 0, 1. So that 0, 2 does this. That's what it creates. I can do exactly the same thing like this. Well, it still gives me a 1-dimensional array, but it pulls out exactly the same stuff.
Yeah, I'm trying to figure out, I'm trying to map it out of my mind. So the 0, 2 is correlating to the
0th row and the first row. Because everything before this comma is looking at row numbers.
Right. Okay, so everything before the comma is the row number, and everything after the comma is the column number.
Exactly.
Okay, there we go. That's what I was trying to figure out. Thank you.
Yeah, no worries. Okay. So we have talked about arrays a bunch. And that is the main thing that we would use in Numpy. But the next thing that I want to talk about is, I'm sorry, I forgot. There are a couple different ways to create arrays. We can create arrays with creating a list and then making an array with the np.array. We can also create arrays using Linspace or arange. So remember, we talked a little bit about range last class. Range in Python allows you to create a list of numbers from the first one, but not including the last one, like all the way up to the last one, but not including it. Arange does the same thing, but creates an array instead. So L5 equals np.a. Oh, sorry. Range. I can do 6. And L5 is now 0, 1, 2, 3, 4, 5. But this is an array and not a list. If we used range in base Python, we would have gotten a list of 0, 1, 2, 3, 4, 5. You can also use the Linspace command, which is very fun. So, Linspace creates a vector that is specifically however many numbers from the beginning to the end. So this one includes the ending number. And so the Linspace takes in 3 things. It takes in the first number that you want to start with, the last number that you want to get to, and how many numbers you want in your vector. Say I want 10. It creates a vector where everything is equally spaced, and it gives you a total of 10 numbers in your vector. Everybody cool?
Yeah.
Awesome. All right. So we can make arrays by converting lists. We can make arrays with arange, and we can make arrays with Linspace. Now that we played a bunch with Numpy, I'm going to move on to Pandas. So Pandas has 2 different data types that are its base. Pandas has series and data frames. Now, the first thing I'm going to talk about is series. And one of the ways we can make a series is also with a list. So we're going to use PD this time instead of NP. And we're going to use series. And then we're going to create a list to go in our series. So now if we do S1, we have a series. And you can see you get 2 different columns here. The first column is our index number. Now it's a little confusing because this is 0, 1, 2, 3, 4 is what's being held in it. So let's change that. All right, so this first column is our index number, so our row number. So the first row is row 0, and in row 0 we have the number 1. Same goes for the second row. The index number is 1, 2 isn't it? The other thing that we get with a series is we get the data type. So the series is all numbers that do not have decimals, So it is automatically typed as integer 64. I could, however, make a series that is strings. Now in Python, I think I talked about this last class, but I'm not sure. In Python, if you have an object that is of type object, that means Python, that's how Python describes strings. So we get our type, and we get a whole bunch of functions. So let's see what functions we get. All right, we've got absolute value, we've got add, we've got aggregate, we've got align, we've got any. So we've got, not only do we have mathematical functions, but we've got Boolean functions. We've got append, arg max, arg min, arg sort, bfill, Boolean, combine, copy, core. Core is one of my favorites. Core will calculate the correlation matrix. Since we only have one column here, we don't have a correlation matrix, but and covariance calculates covariance, cumulative max, cumulative min, cumulative product, cumulative sum, describe. Ooh, I like describe. Let's do that one. So describe takes our series, if it's numeric, and gives us all kinds of different statistics for our series. So we've got the count, we've got the mean, the standard deviation, all the different quartiles, the minimum, the maximum, the 25%.
Oh, I like that.
It's so great. Describe doesn't just work with series though. Describe also works with data frames, and we're going to talk about that in just a minute. But the reason I talk about series first is that when the main type of data that I use all the time are data frames, and data frames basically look just like an Excel spreadsheet where we have columns and we have rows, and each of the columns generally have like a name, for example. But in a data frame, each column is a series. So data frames are just made up of a bunch of series. Okay, so I pulled in this data at the very beginning. I don't know if everybody could see that link that I went to pull in the CSV. See, we're in data, master, iris.csv. If everybody could copy that link, that would be awesome. I'm going to give you a second to do that. Or actually, you know what? I'm going to copy this piece of code and put it in the chat. There you go. Now, like I said, the two main data types for pandas are series and data frames. Now, pandas has a ton of different functions for reading in data, but data read in via pandas generally comes in as a data frame. So iris is a data frame. So let's look and see what iris has in it. So Iris looks like it has 150 rows and 5 columns. We've got sepal length, sepal width, petal width, and species. Iris is a type of flower, in case anybody didn't know. So you can see that Iris has 4 columns here that are numeric and 1 column that is a string. We can do iris.dtype. Not a function. What? So we can see that the type of our data frame, or the type of our variable, is a data frame. We can also get our drop-down menu of everything we want to do to a data frame. We can change the type of the columns. We can convert it. We can look at all the different types of data in our data frame. So you can see that the first 4 columns are floats, which basically in Python is anything that has something beyond the decimal point. So since it's 6.5 instead of 6 even, it's a float. And like I said, the 1 column that's string is labeled object. We can do the same thing with Iris that we did with our series. We can use .describe here. And since we have 4 columns that have numeric data in them, I expect to get data about all 4 columns. And I do. So now I have a table of all the different statistics for every single one of the numeric variables in my data frame. You can see that the average sepal length is a lot higher than the average sepal width and petal length and petal width. Standard deviations are pretty small. We've got maximum, the maximum sepal length is 7.9. Pretty cool. Generally, a company that I work with will give me a CSV of some sort, and I'll load it in using pd.csv or pd.read_csv, and then I will have a data frame that I generally do a .describe, .dtypes, and then after I've done all of that, I do some plotting. So before we do any plotting, I actually want to go check out the gallery, the Matplotlib Gallery. So Matplotlib is awesome. It has a bunch of different types of plotting in it. This is the gallery. The gallery has all the different possibilities that you might want. And you can click on each one and get code for how to do the particular plot. So I'm gonna check out this horizontal bar chart. Now, the reason we talked about NumPy is because generally Matplotlib, when plotting, uses arrays or ND arrays. Excuse me. So you can see that the code that you would use to create this plot, the one that's up here, is listed here. Let's see, I want to do a histogram though. Nope. Histograms. All right, so we have imported Matplotlib as PLT, or Matplotlib PyPlot as PLT. And one of the first things that I do always with data is create a histogram. So I'm going to do that. I'm going to look at the distribution of sepal length here. So I can use plt.hist. And then I can go iris. And to access an entire column of iris, or the full series of iris, the full series of the first column in iris, sepal length, I can put in the name of the column in quotes, and it'll pull it out for me. So now I've got a basic histogram. And absolutely, yes. So this data is specifically coming straight from a website, but if you wanted to pull data from your drive, you absolutely just replace a web address with wherever it is on your computer. Okay, so we did a basic histogram. And as you can see, what histogram does is it changes our series into an array first, and then plots a histogram. Now, this is kind of a blah histogram, you know? So let's change it a little bit. Let's play with some colors. I don't want to go that far, but set the face color. So instead of just putting that in, I'm going to hit tab here. And anytime there is a particular parameter that we can put in to our histogram function, it's going to show up as the name of the parameter equals. So any of these things that show up in this drop-down menu that are something equals, that is a parameter for the histogram. So I'm going to put in color red. I'm going to change the number of bins. Let's see what else we can do. Spell that right. Where did the label go? But we can also add things like changing the names on the axes, for example, and adding a title. And there are all different types of like histograms here. So there are 2D histograms. Super fun. Like I said, all of the different types of plots are in the gallery. And I basically, anytime I need a plot, I go to the gallery and pull up the plot that I want and change the things that I want to change. This particular version on the gallery has been using subplots, which is a function that allows you to plot multiple things on the same, or multiple plots on the same graph space. So it plots 2 different histograms side by side here. And the subplots basically are in an array. So you have to tell it how many rows and how many columns you want in your array of plots. And then you access each one of them by the axis output from subplots. So you've got a fig output and an axis output. And the axes are, if you index into each one of them, you can put a histogram on each one. Now, where did we put titles? All of these are using subplots, but I don't want to use subplots. I just want to do it there. No. Still using subplots. Why? That one's super complicated. If you create a plot and for some reason the plot doesn't show up, plot.show or plt.show will make it show up even if it doesn't show for you. CLF clears your figure. For set. I'm looking for the title. It's just title. Now remember I said last class that Python doesn't care which quotes you used for strings, so I can use double quotes or single quotes, doesn't matter, as long as I do the same one at the beginning that I do at the end. Ta-da! And then if I want to add some stuff to the axis, X label. And let's add now we have a very nice little plot. Okay, so we did a histogram of steeple length. I can do, I now take all of this code that I just wrote and do one for petal length as well. Change that 1, 2, 3. Seems petal length is bimodal. Python generally will recognize names of colors, especially colors that we use a lot, like green or red or blue or whatever. I can also put in purple. Other data that I had was sepal width. Label wasn't doing anything for me, so let's just take that back. Purple. Now for irises, so the petal length being bimodal doesn't surprise me, because there are basically 2 different types of irises. Ones that have very, very short petals, and ones that have very, very long petals. I don't know how much people know about irises. The flower. But there are irises like daylilies that have these really long petals that are just like, wow. And irises that have super short petals that look kind of like orchids. So either way, you can do histograms with a bunch of different colors. We now have given each of our axes labels and a very nice title to our plot. So we've done a histogram. The other plot that I definitely wanted to go over today was a scatterplot. So we go back to our gallery and find my scatterplot. All right, alrighty, so I'm going to create a scatter plot with sepal width versus sepal length. So I'm going to do a plt.scatter. And that's what's going to be on my x-axis. That's my y-axis. And then inside scatter, I can also tell it what kind of, I can tell it a lot of different things. I can use alpha. Now the alpha parameter in our scatter plot, and alpha parameter basically is a parameter that we have in all of our different plots, but alpha parameter is how opaque our plot is. So if our alpha parameter is 1, our plot is going to be 100% opaque. Exactly the way it is right now. Alpha equals 1 is the default. If we change alpha to 0.75 or 0.5, however, our color for our plot starts becoming kind of see-through. I'm going to change my alpha to 0.75. But I also want to look at C. So for scatterplots, to change the color, we use the letter C instead of color, like we would for histogram. Then and then I want to change the marker. Now, I need to check and see what the different possibilities are for that. So let's look at the scatter documentation. The nice thing about Python is the documentation is all online, so you can look up anything you need to know in the documentation. The marker styles are all listed here. So I'm going to click markers and look at all the different possibilities. All right, what kind of marker do we want? How about stars? I'm gonna choose stars. All right, so stars is an asterisk. All right, let's see if we got our plot. Okay, and we got a really pretty plot, but it doesn't have a title. It doesn't have an X label or a Y label. Let's fix that. And I misspelled it. Fancy pants. Now we said our alpha equals 0.75. Let's try alpha equals 0.5. Or 0.25. Ooh. Now you can see there are some stars here that are darker than others. Why do you think that is?
That point happens multiple times?
Exactly. There are multiple stars plotted on top of each other. Totally. Okay, so we have gone through Numpy, we've gone through Pandas, we've talked about a couple of the different plots in Matplotlib. Are there any specific things that people would like me to go over? No specific questions? No specific requests of plots you want me to play with, or was that going to be a question?
No, I'm fine.
Okay. Glenn, do you have anything you want me to go over? Okay. Well, I think that concludes class for today. I believe I went over everything I was going to go over. Remember that you can read in a CSV not just from the internet, but also from on your disk, like on disk on your computer. You just have to put in the right path. You can take a list and change it into an array, into a series. Oh, the one thing I forgot to do. I forgot to show you how to create a data frame from a set of series. Let's do that. Oh, what's up?
So I kind of get what MATLAB and the other one, but what was Numpy for? Like, what did we use Numpy to actually do? Like, what was the purpose of Numpy?
So NumPy was specifically for taking lists and changing them to arrays, so we could do math on them. We didn't actually use NumPy for a lot today, but if you're going to use one of the biggest machine learning libraries there is in Python, it's called scikit-learn. Scikit-learn inputs takes two types of inputs: data frames and arrays. So you need to be able to use like NumPy to create arrays for doing machine learning stuff. But also, if you noticed, Matplotlib took our series, the series that we input. So we inputted a series in our histogram, our iris of steeple width, and Matplotlib changed our series to an array to then plot it.
Okay, but I mean, I guess for what we've done with just making charts and graphs, NumPy didn't really factor in so far.
So it was used in the background. You had to import it to be able to use Matplotlib.
So if I had not imported NumPy, Matplotlib wouldn't have worked.
It would not have been able to plot the data frame right.
All right, thank you.
Of course. And, oh, sorry. Where's L3? There it is. No problem at all. All right, so the last thing that I wanted to do was I wanted to show you how to create a data frame from scratch. To create a data frame from scratch, you would, or like without pulling in data, you would use a dictionary. And we would use the data frame function from Pandas. So I'm going to scroll down to the bottom. Is that cool? So we're going to create a data frame. So I'm going to call it DF. And to create a data frame from scratch, I need to create a dictionary. And the way a dictionary works, in Python, a dictionary is created by putting curly brackets around it and putting together keys and values. So my first column in my data frame that I'm going to create is going to be, what do we want to call it? So I'm going to create a data frame of people and types of candy. And so the first column is going to be numbers of people, and the second column is going to be numbers of types of candy. So the first column I'm going to call people, and then that is the key for that column. Now the value for that column is going to be a series. So I need pd.series of, and I'm going to use a list of 3, 6, 17, 8, 14. All right. So 1, 2, 3. I've got 5 different numbers of people. So that's my first column in my data frame. My second column in my data frame is going to be candy. pd.series again, because I need a series. And a list for my series to take from. And 5, 3, 2, 7, 1. Now I'm going to hit Shift Enter because that's one way to run each of the cells in your notebook are either to click the Run button or Shift Enter. So now I can display my data frame with people and candy. I can do df.describe like I did before and show you the different statistics for the different columns. So this is if you wanted to create a data frame from scratch instead of loading it in as a CSV or from a CSV or from an Excel spreadsheet or from a SAS file, because you can do that. Pandas has a ton of different read-in functions, so it's not just CSVs. But sometimes you want to create one from scratch, from sets of series. Now, if I pull out a specific column of my data frame, I get a series. A named series, but a series. Now, if I just want the values in my column, I can do, or in my series, I can use .values. And that's an array. If you do math on any of the series in your data frame, you're basically using all the functions in Numpy. So Pandas is kind of built on top of Numpy. Okay, are there any questions as of this moment? Are there any requests for me to go over something specific? Okay then. Well, I declare this class, oh yeah, so I generally use dimensionality, well, okay, it depends on what you mean by dimensionality reduction, Tavi. PCA, you mean? Python can absolutely do phase-space methods in PCA.
I'm meaning some people say PCA, some say ICA, principal or independent, or
Right, exactly. So Python can definitely do that. What you would want to use is scikit-learn, the machine learning library that has PCA in it.
how do you spell that? Oh, scikit. Okay.
Yeah. So scientific kit of machine learning.
Yeah, I'll definitely want to take a look at that.
I've been requested to do a class on scikit-learn, so I'm probably going to do a class on scikit-learn later in the month. It won't be next week because next week I'm going to do another class on R.
I might be interested in that too.
Cool.
Right,
all of
cool.
the classes on R, all of these classes have been posted on YouTube. So if you want to go back to any of the classes that I've taught, they're all on Veronica Red's YouTube channel. There are 2 classes there for Introduction to R. The Introduction to Python class that I taught last week is up there as well. And this one will be up there as soon as the recording is available.
Sounds good.
Awesome. Well, then I will let everybody go, and I will end the recording for today. Thank you, everyone, for being part of class and asking great questions, and hopefully I will see you again.